heat. Hot and cold. Our daily experience tells us that some objects around us are hot, whereas some are cold. Some objects are hotter than the others, while some are cooler than the others. We often find hotness or coldness of an object by touching the objects, but our sense of touch is not reliable. Our senses provide us with a qualitative indication of temperature. However, our senses are unreliable and often misleading. Therefore, what we need is a reliable and reproducible method of establishing the relative hotness or coldness of bodies. A reliable measure of the hotness or coldness of an object is its temperature. Temperature is measured by an instrument called thermometer. Scientists have developed various types of thermometers for making such measurements. Measuring temperature. When you have fever, your doctor uses an instrument to measure your temperature. This instrument is called a clinical thermometer. Thus, a clinical thermometer is one which measures our body temperature. Nowadays, a digital thermometer is also used. A clinical thermometer is a mercury in glass thermometer with a short temperature range of about 35 degrees Celsius to 42 degrees Celsius, 94 degrees Fahrenheit to 108 degrees Fahrenheit. A clinical thermometer consists of a short, narrow, uniform glass tube with a bulb at one end. The capillary tube of it is of very fine bore to make it more sensitive. The bulb has very thin walls so that the mercury in the bulb quickly acquires the temperature of the body. The bulb contains mercury or alcohol. Outside the bulb, a small shining thread of mercury or alcohol can be seen. If you are unable to see the mercury thread, rotate the thermometer a bit till you see it. You will also find a scale on the thermometer. The scale we use is the Celsius scale, which is indicated by degree Celsius, or the Fahrenheit scale, which is indicated by degree Fahrenheit. Precautions while using a clinical thermometer. The following precautions should be observed while using a clinical thermometer. Thermometer should be washed before and after use. Ensure that before use the mercury level is below 35 degrees Celsius. Read the thermometer, keeping the level of mercury along the line of sight. Don't hold the thermometer by the bulb while reading it. Never use it for measuring the temperature of any object other than the human body. Laboratory thermometer. The common laboratory thermometer consists of a long, thick-walled capillary tube with a thin-walled bulb containing mercury or alcohol at one end. The other end is sealed. The range of ordinary laboratory thermometers is -10 degrees Celsius to 110 degrees Celsius. Using the laboratory thermometer, take some warm liquid in a container. Dip the thermometer in it so that the bulb is immersed in the liquid but does not touch the bottom or the sides of the container. Hold the thermometer vertically. Wait for some time till the mercury thread in the thermometer becomes steady. Do not remove the thermometer from the liquid. Now, note the reading. This gives the temperature of the liquid. Transfer of heat. It is a common observation that a utensil, when placed on a flame, becomes hot. It is because the heat passes from the flame to the utensil. When the utensil is removed from the fire, it cools down slowly. In both cases, heat flows from a hotter object to a colder object. It means that transfer of heat takes place only if there is a difference in temperature between the object and the surroundings. The transfer of heat takes place in three ways. These three ways are conduction, convection, and radiation. Conduction. If you have ever cooked on a barbecue with metal skewers, the metal over the burning charcoal becomes hot and the heat energy is transferred along the skewer by conduction. In metals, this takes place quite rapidly, and soon the handle end is almost as hot as the end over the fire. Metals are good thermal conductors. If you use skewers with wooden handles, you can hold the wooden end much more comfortably because wood does not conduct thermal energy very well. Wood is an example of a good thermal insulator. Do all objects conduct heat easily? We have two types of objects. One which conduct heat easily and second which do not conduct heat. They are respectively called conductors and insulators. Thus, good conductors are the substances which readily conduct heat. Example: silver, aluminium, iron, copper, brass. Whereas insulators are the substances which do not conduct heat. Example: water, air, felt, asbestos. Convection. The heat transfer takes place in substances like water and air through a process called convection. Convection is transfer of heat by mass motion of a fluid from one region of space to another. Familiar examples include hot air and hot water, home heating systems, the cooling systems of an automobile engine, and the flow of blood in the body. Convection in liquids and gases can be demonstrated with the following experiment. Drop a few crystals of potassium permanganate down a tube to the bottom of a beaker containing water. Now, heat the beaker. We find that purple streaks of water begin to rise upwards from the crystal and spread out. This is because the hot water, being less dense than cold water, rises up and its place is taken up by cold water. This sets up convection current in the water and the purple streaks follow this convection current. When the whole water acquires a steady temperature, no more streaks are seen to rise from the crystals. As gas molecules are freer to move about than liquid molecules, and as gases expand very much with increase in temperature, convection occurs much more readily in gases. Sea and land breeze. Natural convection cycles occur in liquids and gases. For example, when cold water is in contact with a hot object, such as the bottom of a pot or a stove, the object transfers heat to the water adjacent to the pot by conduction. But the water carries the heat away with it by natural convection, and a cycle is set up in which upper cold water replaces the rising warm water. Such cycles are important in atmospheric processes. During the day, the ground heats up more quickly than do large bodies of water. This occurs both because the water has a greater specific heat than the land and because convection currents disperse the absorbed heat throughout the great volume of water. The air in contact with the warm ground is heated by conduction. That air expands, becoming less dense than the surrounding cooler air. As a result, the warm air rises, air currents, and to fill the space, other air moves horizontally, winds, creating a sea breeze near a large body of water. Cooler air moves down and a thermal convection cycle is set up, which transfers heat away from the land. At night, the ground loses its heat more quickly than the water, and the water surface is warmer than the land. As a result, the cycle is reversed and a land breeze flows. From the above two heat transfer mechanism, we find that a material medium is required for transfer of heat to take place. From the sun, the heat comes to us by another process known as radiation. Radiation. Radiation is the process of transmission of heat in which heat travels directly from one place to another without the agency of any intervening medium. When we sit in front of a room heater, we get heat by this process. When you keep your hand close to an electric iron, you can feel the heat coming from it. This heat is also transmitted through radiation. A hot utensil kept away from the flame cools down as it transfers heat to the surroundings by radiation. Our body too gives heat to the surroundings and receives heat from it by radiation. All hot bodies radiate heat through the process of radiation. Difference between conduction, convection, and radiation. The following are the differences between conduction, convection, and radiation. Conduction, convection, radiation. The transfer of heat from one point to the other such that there is no actual motion of the particles of the medium is called conduction. Convection is transfer of heat by mass motion of a fluid from one region of space to another. Radiation is the process of transmission of heat in which heat travels directly from one place to another without the agency of any intervening medium. Material medium is necessary for this process. Material medium is necessary for this process. No material medium is required. It is not possible in vacuum. It is not possible in vacuum. It is possible in vacuum. The transfer of heat can be in any direction along any path. The transfer of heat takes place in a vertically upward direction only. The transfer of heat is in all directions along straight line paths. The process is slow. The process is faster than conduction. The process is faster and takes place with the speed of light 3 into 108 meter per second minus 1. Good and bad conductors of heat. Every hot body emits radiations. The amount of radiations emitted by a body depends upon its surface. A dull surface coated with lamp black or platinum black emits more radiations than emitted by a lightly polished surface. It is also observed that a dull surface has the ability to absorb more heat radiations falling on it than that absorbed by a polished surface. Let's perform an activity to understand. Take two identical steel utensils. Paint the outer surface of one black. Pour equal amounts of water in each and leave them in the midday sun for about an hour. Measure the temperature of water in both the utensils. You will find that the water in the utensil which is painted black is warmer than the water in the other utensil. This is because dark or dull surfaces absorb more heat than bright or shining surfaces. Now, place the two steel utensils in the shade. After some time again, measure the temperature of water in the two utensils. It will be observed that the water in the utensil painted black will be cooler than the water in the other utensil. This is because dark or dull surfaces readily radiate heat as compared to light or polished surfaces. From the above two activities, we conclude that good absorbers, black surfaces, are good emitters, whereas poor absorbers, polished surfaces, are poor emitters. Personal insulation. Thermal insulation means preventing transfer of heat energy from and to the device or the system. Body temperature of a normal healthy person is 37 degrees Celsius. This is maintained by the continuous production of heat energy from the food we take and the movements we make. A delicate balance is maintained between the heat produced inside our body and the heat lost to our surroundings. When outside temperature varies, our body has to be provided thermal insulation. During hot summer days, our clothes, being very poor conductors of heat, help insulate our body from the heat outside. In winter, the need for thermal insulation is very important to prevent loss of heat from our body to the air outside, mostly by conduction and convection. So, we wear woolen clothes, sweaters and jackets, which form several layers. In many countries of the world, cold weather is a major problem. Cavity walls and hollow bricks help in reducing loss of heat from inside the house. As air is a better insulator than bricks, the introduction of cavity walls improves thermal insulation. Double-walled windows improve insulation by trapping a layer of air between the two sheets of glass. The extra thickness of glass and layer of air increases insulation, as both glass and air are very good insulators.